Okay, on lesson 9, page 217, problem number 3, you have hail that's bouncing down and hitting the roof of the car, and then it's bouncing back up. And I think this is the essence of the question. Basically, you know how impulse equals change in momentum, and impulse equals force times time, and change in momentum equals the mass of the object times the final velocity minus the mass of the velocity times the initial velocity. And basically, this little hailstorm little nugget thing right there, it's going to go through a serious change in momentum, because it's going down with a velocity, and when it hits the roof, it bounces back up with a certain velocity. So the roof is definitely putting an impulse on that little hailstone, changing its momentum. Now, the thing that you have to really watch out for with this change in momentum right here is that you have to include direction. Now, did they give you the little velocities of the two, or not necessarily?
Yeah, they did.
So,
bounces off the roof of the car with a velocity of plus 15 meters per second.
So it's going plus 15 meters per second on the way up. And what about on the way down?
It doesn't say, but if you look at example 2, it says like negative 15 meters per second.
So sometimes people think that the change in velocity is going to be 0 because it's like 15 minus 15. But if you really watch carefully, you know what I'm going to do? I'm going to factor that m out over here. I don't know what the m is. I'm just going to factor that m out right here. So m equals df minus di. So the final velocity is going to be positive 15 meters per second minus the initial velocity is going to be negative 15 meters per second. So the change in velocity, what does it turn out to be? Positive 30 meters per second. And I'm wondering, did they give you the mass and the time and they're asking for the force, or?
It says, it just disregards the time.
So it's probably
If you divide by t,
So like, yeah, if you divide by t, you get force equals the mass divided by time. That's how much hail is hitting the roof of the car per second. The amount of mass that's hitting the roof per second times the positive 30 meters per second. And they tell you in the problem that the mass per time, how much hail is hitting the roof per second is how much?
0.060 kilograms per second.
So they gave you this right here in a weird kind of way. And now you have the change in velocity, and you could solve for the force, which is what the question is asking.